All right. So we're just going to review central tendency. And central tendency is basically, and I got all the definitions up here, it's the one value that best represents all the data that you have. So whatever set of data you have, it is the number, the one number that represents all of it. Some people will say, like it says up here, it's the middle of the bunch of data. And central tendency, a lot of you probably have heard of the terms mean, median, and mode. All three of these things are part of central tendency. They are measures of a central tendency. And we're going to go through that. So I have a problem here. We have YouTube uploading times. So there are 6 files that have been uploaded to YouTube, and here are the lengths in minutes that it took for these to be uploaded. That is good. And I just drew a little nice graph there to show these values as well, or show these times. So we're going to calculate mean, median, and mode and decide on what is the best measure of central tendency. So the first thing I'm going to do is I am going to write out these this data set in order, and it's very important to do that first, and we'll go over why. So our first is a 2. Oh, that's not showing up. 1 second. All right, sorry about that. Trying to get used to this again. So we have a... What are you doing? There. So we have a 2. The next one is a 10. Then we have a third file that took 10 minutes. A fourth file that took 11 minutes. Another file that took 12 minutes, and one that took 15 minutes. All right, so we have those 6 files there in order. So what we're going to do is calculate the mean. Now the mean, as it says up here, is basically the sum of these values. So you add them up and you divide that by the number of values that you have. So I add up these values and I divide by 1, 2, 3, 4, 5, 6 files. All right, so when I add up these, they will equal 60. So that's my sum. Now I need to divide that by 1, 2, 3, 4, 5, 6. And my answer is 10. So if I were to calculate the mean is saying the number that best represents all of this data is 10. But there's something very, very interesting with this set of data. Remember, the definition is the number that best represents all of the data. If you look at all of this data, does this number right here, is that in line with the rest of your values? Is that similar to the rest of your values? No, it's very off. It's much lower if you look at the rest of the values. And this is something that we like to call an outlier. And an outlier is any value, it could be very low or extremely high, that is not part of what you see or not similar in your range of the rest of the data. And the mean, if you again calculate the mean, you are calculating all parts, all sets of data. And if you only have 6 numbers in your data, this value here that's so low is actually going to bring your mean down. Or if it's extremely high, it's going to bring it up, and it's going to affect your data. So when you only have a small set of numbers, using the mean may not be the best way or best central tendency to use, because these outliers will affect your mean dramatically. And therefore, it may not be the best number that represents your data. So there are a couple things you can do about that. One, you could basically recalculate the mean without the outlier and see what you get. So we'll try that now. Okay, so if I were to add up now these values here without the 2, basically you're taking 2 off, so instead of 60, these values, these values here will equal 58 if you add them all up, because taking 2 away from 60 is 58. But now we have to divide that by 5 because we're not including the 2, so the number of values is 5. So 58 divided by 5 is actually 11.6. That is so different from our previous answer of 10. So taking this value away brings our mean all the way up to 11.6. So that is one way, but again, the outliers won't affect the mean much if you have a large set of data, but because we only have 6 numbers here, it does affect it, as you can see with our results. So the other thing you can do if you have an outlier and you want to get a true central tendency, a true measure, is calculate the median or the mode. So mean is 10 or 11.6 without the outlier. So let's calculate the mean. Okay, so the median, and this is the reason why you have to put these values, any values, in order. You want to make sure they're in order because the median is the number that is directly in the middle of your set of data. So whatever's in the middle, that's the median. Just like when you're driving, the median is that little island in the middle of the road. So let's figure out what the middle is of your set of data that is in order. So that can't be it. Take 2 off on each side. So these 2 numbers here in the middle, we do not have a value that is directly in the middle of your set of data. Here's a little hint. If you have an even number of values, you will not have a number that's in the middle. If you have an odd number of values, you will have a number that's in the middle, and it's easier to calculate the median. But here, it's actually fairly easy to calculate the median. You've got 2 numbers without a number that's in the middle, 10 and 11. Now we know the middle number is 10.5, 0.5 being halfway between 10 and 11. So that is actually our median, 10.5. Now, if your numbers are not nicely close like that, so let's say you've got 2 numbers there that are much farther apart, to get that middle number, you're basically calculating the mean again for these 2 numbers. So in this example, will be 10 plus 11 divided by 2, and that'll give you 10.5. So that is the median, and the median, when you have a small set of numbers, might be the best measure central tendency because, well, the outliers don't affect it that much. But it is interesting to see in this case, 10 and 10.5 is fairly similar. Let's move on to mode. All right, so the mode is the number that repeats itself. It's the number that occurs most frequently in the data, and it's the easiest one to calculate. We have a 10 and a 10, and no other numbers repeat itself. So your mode is 10. So the question is, we've got 2 10s and a 10.5. What number best represents this set of data? Is it 10 or 10.5? Some people, or majority, you'd probably want to argue actually that the best number to represent this data is 10.5 because it's a small set of numbers and there's an outlier that would affect the mean. So 10.5, that's probably your best number that represents this set of data. So there's a number of ways to look at that, a number of ways to calculate it. And it's also interesting to, again, see how much the mean is affected if you take out the outlier and you recalculate it. But it may affect your average way too much. So those are some things that you want to keep in mind. Ideally, you want your 3 values, both mean or all 3, mean, median, and mode, to be very similar, and that should give you a better indicator of your download time. So the number that best represents this set of data, 10.5, 10, you decide. But it is around that range. That's central tendency, mean, median, mode. All right, bye.